Hi everyone, I'm Ali, and I'm going to talk about my joint work with Maurice Hart on what makes ImageNet look unlike LAION. So let's get to the question. We have seen ImageNet for a while. This is the workhorse of computer vision for nearly a decade, and it was created by querying some image search engines and doing human filtering afterward. In recent years, however, we have seen this massive scale LAION dataset, which is just some crawled image text pairs filtered automatically by some clip model to ensure that the image and text are relevant. Interestingly, LAION has taken the field by storm, and we have seen new generations of very successful models trained on it. So this raises the question of what makes LAION and ImageNet really different. And when I ask that, we know that LAION has a massive scale and it has language supervision, so I don't mean this. I exactly mean for the same task, what makes them different. And this task is the task of image classification for 1,000 classes which are present in the famous ImageNet 2012 dataset. And we want to see if LAION could contribute anything that ImageNet has not contributed to this task. So the way we answer this question is to create a new ImageNet dataset by querying LAION. So at the outset, LAION is just much like a text-based web image search. We can specify a query and retrieve images that have high similarity between that query and the text surrounding the image on the website that it was crawled from. In this way, we create a new dataset, we call it LAIONNet, and then compare ImageNet and LAIONNet. So why is it interesting? Because by this comparison, we're going to have some new insights about both ImageNet and LAION. And I think we're going to have some recommendations for future dataset creation efforts. Now, let's see how LAIONNet is created. But before that, let's just recall how ImageNet is created. And by ImageNet, I specifically mean the ILS-VRC 2012 version. So we had 1,000 classes. They correspond to 1,000 so-called scene sets in WordNet. For every synonym in scene set, what ImageNet data collectors have done is to query some image search engine, obtain some candidate images, and then ask human labelers to choose between them. This is how ImageNet is curated. And we want to mimic this process as much as possible. So we start from the same set of synonyms, but now use the LAION as our image search engine. So in LAION, we have some image and text pairs. What we do is some sort of text-based selection. We do this conservatively in the sense that we want to make sure that when a sample is chosen, with very high probability, it corresponds to the class we were seeking. So this process has multiple steps. In the first step, we make sure that the synonym name is exactly repeated in the caption of the image. Then we make sure that the synonym and the definition we have for the synonym is very similar to the caption that the image has semantically. Thanks to the NLP advances, we can do this with high quality and high confidence. We also have some safety and additional measures to make sure that this is a good match. By doing this process, we're going to have a new data set, which we call LAIONNet. It's going to have about 800,000 samples from more than 900 of the classes which are present in the ImageNet. And of course, unlike ImageNet, which almost has equal probability classes, different classes are going to have different frequency in LAIONNet. Okay, what are our findings? In a nutshell, the first thing we observe is that ImageNet definitely looks very different from this LAIONNet that we created. How do we measure that? What we do is that we use some ImageNet trained models and measure their accuracy on LAIONNet in a way that this number is comparable with the original accuracy on ImageNet. And we observe that this accuracy significantly drops on LAIONNet. Does that mean that LAION images are very harder to classify? It turns out that this is not the case because we use other methods to see that, for example, when you use clip zero shot accuracy, there is no evidence that LAION images are harder. So the only way we can explain this difference between the accuracy on ImageNet and LAION is the additional diversity that the images have in LAION. We give a formal explanation for that. So if LAION images are more diverse, why is it that? And we answered that by identifying a difference in the data generating processes of the LAION and ImageNet. So stay tuned. I'm gonna describe them. Let's get to the first finding. Let's first see why ImageNet is not similar to LAION. Okay, as I said, what we're gonna do is to compare the accuracy of some classifiers trained on ImageNet on LAION. We choose a wide set of classifiers, including ResNet and visual transformers and convex. And what we observe is that when we look at the accuracy on LAION versus the accuracy on ImageNet, the accuracy on LAION is often 10 to 15% lower. And this is consistent for almost all the models that we have. And just as a side note, we know that ImageNet validation set has 50 images per each class, but this is not the case for LAION. However, since we want to make sure that this comparison is actually valid, we calculate a weighted accuracy just to make sure that each class is equally represented in the LAION. That's the first observation. And as I said, we don't have any evidence that LAION images are actually harder to classify. One way to see this is that if we look at the clip zero shot accuracy, there's not that much difference between the LAION and ImageNet. Okay, so if LAION images are not more difficult than ImageNet, why is it that ImageNet trained models struggle on LAION? And we explain this by the diversity of the images in the LAION. The formal definition that we have for diversity is this notion of intra-class similarity of images. So fix a class, the way we calculate this similarity is that we average pairwise similarity of the images in that class, and we use a cosine similarity of the clip embeddings to calculate this similarity. This is called intra-class similarity of images. A higher intra-class often means that the images in that class are less diverse. Okay, if we look at the distribution of intra-class similarities across the classes, more than 900 classes which are present in both datasets, we clearly see that LAION images are more diverse. In particular, in more than 70% of the classes, LAION has significantly lower intra-class similarity than ImageNet. Great, let's look at two examples. The first one is this class Torch. And here we have some images from LAION and ImageNet, and we can see where a visual transformer trained on ImageNet error on LAION. And when I say that it makes a mistake, I mean that the target class is not among the top 5 predictions. In this example, we can see that ImageNet trained examples struggle when the torch is not a real torch, it's just a graphical depiction. And we observe something interesting in the class pillow as well. Whenever the pillow is in some context or it has some weird shape, which is not rectangular shape, then we see that the ImageNet trained model struggles. This is kind of the diversity that we see in LAION, which is missing from ImageNet. Now let's get to the question of why. So why LAION images show more diversity than ImageNet? Okay, what I'm gonna do, I'm gonna describe a data generating process and then explain why the data generating process of LAIONnet is very different from ImageNet, and that can cause more diversity. Consider this data generating process where for every class Y, an image can be generated. In case of LAIONnet, we can assume that this is a joint distribution, so the text and image will be created from this category Y. So when we collect a data set, ideally we want to sample from this distribution, which is the distribution of the images conditioned on a specific category. But we don't have access to this generating process. In contrast, what we always have is just a large pool of candidates, and we have to select which one of them we want to assign to this specific class Y. So formally, there is a selection process which can use both the text and image data, and this is going to be the distribution of our data set. This is the distribution of the images conditioned on selection. All right, what I'm going to argue in next few slides is that we would like to avoid this link as much as possible, because this can cause a lot of selection bias in our data set. For example, let's say some images are just more beautiful or just easier to identify. And by conditioning on the image content itself, we are making the selection process more vulnerable to selection bias. Let's make that formal. I'm going to start from the LAIONnet data collection process. We intentionally avoided this link as we use the text-based selection. And so this is how the data generating process looks like for LAIONnet. Let's fix a class Y. This is the distribution that we are sampling from. Since we had a lot of measures and we chose a lot of things conservatively, we can say that with high probability, this distribution looks like this. In other words, whenever we have selected an example, we have selected that from the right class. This is the right target class. That's the first part. We also know that this selection is only text-based selection. Now, here is the last step. I'm going to argue that this is actually our desired distribution, which was X conditioned on a specific Y. Why is it that? Because we know we are conditioning an image on some specific text, but we know that the image has much more information than the text. So I can argue that by conditioning on the text, we are less likely to be biased in terms of the information that are present in the image. If I want to present this on this causal graph, I would say by conditioning on the text, since we are not directly observing the image, and since a lot of information is lost going from the image to text, we're just less vulnerable to have a selection bias. So in this case, we say that the text is working as some sort of information bottleneck. Okay, this is not happening in the ImageNet case. If you look at the ImageNet, there's a strong link from the image to the selection. Why is it that? There might be multiple reasons. For example, human annotation. When humans look at the images and decide whether this has the target object or not, there might have some biases like looking for beautiful objects or looking at an object which is easy to identify or at the center of the image, as we observed in the two examples that we had. So there are multiple reasons that the humans might be biased here. Another reason might be in the step where we created the candidate pool of the images, we used some image-based search engines, and these search engines often show popular images first, and popular images turn out to be more beautiful images. So that's another place that the bias might be introduced into the selection process. Okay, so far I explained the difference between the causal generating processes of the LAIONnet and ImageNet, but I haven't yet shown you any empirical evidence that this is actually the case. we know that the link from X to S doesn't exist, but why is it the case that there is such a link in ImageNet? And actually, how strong is that link? Does that matter or not? For that, we provide 4 independent experiments. I refer you to the paper for the details, but in the nutshell, in the first experiment, what we do is to weaken the image to selection link in the ImageNet. The way we do it is to use ImageNet v2. There are multiple versions of ImageNet v2, so we can see what happens when ImageNet v2 relies on less strict human filtering. And what we observe is that ImageNet becomes very similar to LAIONNet when we weaken this image to selection link. On the other hand, if we intentionally introduce a link from the image to the selection in the LAIONNet, we're going to see that LAIONNet becomes very similar to ImageNet. The way we do it is to use the similarity between the image and the query in addition to the similarity between the text and caption. So if we do that by intentionally introducing this link, we're going to observe that LAIONNet becomes very much like ImageNet. In the third experiment, what we do is that we use ImageNet captions. This is a data set of some of the captions that the ImageNet images originally had. Not all of them, of course, but most of them. And what we can do is to see, are the images actually selected based on those captions or not? And we sure know that the text is not enough to explain why this image is actually selected. And that's because there are some images that when we look at the caption, we see that the caption is more similar to other classes than the labeled class. And the last experiment is that we use the ImageNet captions and we try to look for the most similar captions in LAIONNet, generate a data set for that. And we see this data set looks very, very different from the ImageNet. So this is another evidence that ImageNet probably has not been created solely by searching text. Okay, with that, I want to conclude. As a summary, we created ImageNet from LAION to get some insights about their difference. And we realized that the new data set called LAIONNet looks very different from the ImageNet. We tried to propose an explanation for that in terms of the difference of the causal data generating processes that the LAIONNet and ImageNet have. In particular, we explained that this image to selection mechanism might be the reason that we see a lot of the diversity lost in ImageNet data generating process. And this comes with some advice for future data set generation. What we advise is that whenever diversity is desired, you want to have a representative example for your concept, then maybe this is a good idea to have some sort of information bottleneck, like the succinct text caption that we had. I would like to also emphasize that previously the diversity of the images in the LAION was cited as the reason behind the robustness of contrastive language image models. And our work kind of demystifies that and explain what is that distributional advantage of LAION. Of course, in addition to the massive scale and the language supervision, but LAION also has this distributional advantage. Thank you so much, and feel free to reach me at this email.